Welcome to this lecture. In this lecture, we'll talk about Tor browser. So first of all you need to do is simply go to the Google and search for this Tor download. I'll just click on this link and it will just redirect us to this page. I'll just install VMS Windows, or basically for this MS Windows. So if you see here, it will just give the Tor browser and your bit version, and I'll just go to this 64-bit and it will give us the link. I'll just save this file and it will be downloaded over here. So after you just download, it is a quick installation procedure. You should get this folder and it will say that it has the start Tor browser. So it should appear after you just install to that on your system. So let me just close this because I have already installed, and you will see this start Tor browser icon over here. So let me just open this. Then you should get this Tor browser establishing a connection tab. Let it give a time to load and it will just give us this Tor browser. So this is the Tor browser that is going to just open us the hidden websites that is in the dark web. So it is completely normal to use those onion website, but if you just use something for the bad intention, or basically if you do something that harms other, and basically if you do illegal stuffs on this store, it is completely illegal and you will just get involved into the action that will just take by the police. So I'll just suggest you, so basically you can just get ideas of these store websites, or basically the onion route link. We'll also see how to make our own onion route link, or basically our own website on the dark web in the next lecture. But for now, let me just go to the interface of this Tor browser. So you could see that it is showing us DuckDuckGo, same as Google search engine. So this is the Google search engine in the Tor browser. So you could see this DuckDuckGo is very much reliable than the browser, that is Google browser, because this doesn't track you. So it is a very important feature of this DuckDuckGo. So you can search anything over here. So just you need to remember that any website that is visible in the normal server is also available in this Tor browser. So if you go here in our normal Firefox, you will search for the Facebook. It is also available in the case of the Tor. That means it will be available, that is this .com website, or basically if I just search for this facebook.com, then you will see that it will also load this facebook.com over here. So that means we can search the normal websites, or basically deep websites that starts, or basically that ends with the onion route or onion link. Like let me say this is the onion route. So this website can be also served in the case of the Tor browser. So just remember that. So this website will be also available over here. So just remember that is basically normal websites, and the deep link websites will be available to serve in the case of the Tor browser. So let me just open some of these websites. So before that, let me see what is over here. So at the corner, at the left hand side, you'll see that we have this onion sign over here. So let's click on that symbol. You'll just see the options that will pop out over here, saying new identity, security settings, Tor network settings, and check for the Tor browser update. So if I just press on this new identity, that means it is going to give us another identity for us, that is a new network connection. We'll see about the connection in a minute, how this Tor onion route works. We'll see all of this mechanism in a minute, but before that you can do that is click on this new identity. You will just get the new identity, new connection, or a new circuit for your connection. And if I just go to this security setting, you will just get this browser setting over here. It is in the standard, that means all the Tor browser and website features are enabled. If I just go to the safer mode, you will see that it is just lacking some of the features, like JavaScript is disabled on the non-HTTPS site. That means it will be the safer than this standard, but it is likely be more safer. That means it is more secure system than before, because it will have these settings that is enabled or basically disabled, so that it won't be tracked by any officials. So that means you will have the JavaScript that is disabled, some fonts and math symbol are disabled. So if I just go to the safest mode, you will see the features will be just disabled over here. So HTML5 medias are click to play. So if I just press on this safest mode, and now if I just go to the maybe YouTube, so if I just play the YouTube, you'll see the drastic changes. So if I just go to the YouTube, let me just close this tab, and it is going to load us in a minute because it has to go through different servers, so it is usually taking time than what we normally search in the case of a Firefox. So let it give a time to load. So it is taking the time than I estimated, so let me just play it again, or basically maybe okay. So you could see we are in this safer mode. So basically if I just go to the standard mode, and if I just press enter again, you will see that we will get now the normal website, that is YouTube website, which will have all the features like this. So it has the JavaScript enabled and everything. But if I just go to, maybe let me just go to the safer mode, not the safest mode. So let me just press OK, and now if I just play it again, then you'll see the lots of feature will be disabled over here. So I think I haven't saved that. Okay, so something like if I just play this video, you'll see that. Okay, let me just go back and play this video maybe. Now you will see that it has lagged some of the features. So it has lagged these features. So let me show you. So these were the security settings that were just lagged. So JavaScript is disabled on this non-HTTPS website. So that means some of the features like the gesturing and everything, that is DOM manipulation, has been disabled in this website. So that means this is more safer website than before, because this cannot be traced easily than that which was before. So next setting over here, so let me just close this one, and the next setting over here is a TOR network setting. I have to open that, and you could see I use a proxy to connect to the internet, this setting over here. Let me open that, and it is giving us some options. So if I just type the proxy, maybe SOC 5 or SOC 4, if I just open this website, which is maybe SOC proxy website, this free socproxy.net website, you can get this proxy from here. So these are the SOC 4 proxy, so you can just get those, and simply what you need to do is simply take these IP addresses, and these are free. If you want to buy the proxy, it will be faster than this, but if I just want to just give you the example over here, you can simply add the IP address, you can get the port of that IP address from here, and the username and the password over here must be optional. So after that, you'll just click OK over here to run your SOCs, and basically now we have successfully added that proxy to this TOR. But I won't be adding it. So you could see how to add the proxy, how easy it is to add the proxy to the TOR browser. So next thing in this TOR browser is this extensions, which is freely downloaded while we just download this Firefox. So let me just go to maybe here add-ons, and you will see it has the HTTPS everywhere, no script, TOR button, and TOR launcher. So these comes pre-packed while we just install the TOR browser. That is saying no script, that means it will just have the extra protection for this Firefox or for this TOR browser. So this is the extra feature that we get is pre-downloaded with the TOR. So we can source many websites, that is only a link in this TOR browser. So before that, let's see how this onion route work in the TOR browser. What is the mechanism of just making so secured system? So how these systems can be so secure that it is very hard to just trace by the officials. So let's see how this works. So basically, let's see how TOR browser works under the hood. So let me open my document over here. Let me grab my pen. So let me just grab this pen over here. Now you could see that, let me just grab it here. So you could see this is our internet over here, and it is the man, or it is the client who is basically surfing that internet. Maybe I want to get google.com. so you could see the server over here saying that this is DNS. That means it is a domain name server. So anything you type over here is going to be, so let me say give a quick example what is happening over here. So if I say something like www.google.com, so I won't type I will just type z as google.com, and if I just solve this internet, then it will just go first to this domain name server. It will just check that google.com and it has associated IP with it. So this IP is basically the way to just determine that it is related to google.com. So this is the IP that is particular to google.com. So that can be done. So something like, if I just go over here and ping my google.com, you will get the IP of the Google. If I see here that this is the IP of the Google, you can clearly see over here. So this is the way where we can just get the IP address. So that is done by this domain name server, because internet only gets idea of this number, so they don't know anything about this. So google.com for this internet is just a gibberish. So first of all, we have to convert this google.com, which is basically the name that is given by the humans, because just remembering these characters, this number for the human is very tedious. So they have just given the name so that the remembering this name would be easier just than remembering these IP addresses. So basically DNS server will convert our domain name to the IP addresses, and after that domain name, or basically after that IP addresses is given back to the client, it will just give it to the ISP, which is your internet service provider, and through this internet service provider they will just make a request to the internet to fetch the website of the google.com, and this is the website server which has the address of 111. That means it is the website of Google. So it will just give you the page of the Google. So this is the way how the internet works. But you can see there is no security at all. So what if we just came as a man in the middle over here and we just grab that pages or anything, or basically your location or the data, so anything you have searched here can be just vulnerable. So you can clearly see over here that the data is not encrypted. It is not through the encryption, it is just sending the request through the ARP protocol, which is very vulnerable. So there comes the handy technique, which is this onion route. So let's see how this works. So you could see that it is the same picture that we just see, but now we have the different servers. So you can see these A, D, G are the servers. So they are located just normally or located remotely in the all of the locations that is throughout the world. So basically what happens now is, if you just give the address that is your IP address, and now instead of just let me show you the example that we are just going to search for maybe Toyota car in google.com, which has the IP address of this 1.1.1.1. so you can see that the only thing that this server can track is your IP address and the things that is your data. So you can see that this server, which is the google.com, can just trace you back or get every information that you just do in the internet. That means this is not secure. So let's see how now onion routes makes this data encrypted. That means our connection or the network will be more secure than before. So first of all, you will have the information that is saying, hey, I want this data. So this will be gone through this server. So data will be encrypted first to this. So first of all, what happens is, so first of all, let me say you that this sends data from here, that is 1.1.1.1, and first of all it should go through this. So basically this is the first server that this will just get communicate to. So this will send that data to G server, and basically after that you can clearly see there is a layer of encryption over here, because if you just see every layer has its encrypted key, that means it will just get a time to just encrypt one layer of encryption. That means only one part of the messages will have to be only encrypted or basically decrypted by each of these server, so that the encryption will be much more efficient than before. So let me show you what is I'm just talking about over here. So let me just go to the documentation of TOR project over here, and you'll see that how this TOR works basically. So let me show that Alice is the one that is going to be giving the source, and you can see this dev is the another client that there will be the message encryption. in between them. So first of all, what happens is Alice is just asking for the TOR nodes. So we have the TOR nodes, that is basically the server that is associated on different location. So they have the TOR nodes. So they are basically the TOR nodes or the directory server, and after that they will just get that TOR nodes list of the TOR node for the Alice, and basically now encryption happens in the next step. So you can see that over here that these circuits are so encrypted that every encryption have its encrypted and decrypted key over here. So you can see this is the encrypted circuit over here, and this part, which is this part, is your TOR node. So this is your TOR node, or basically this is your encrypted link again, but this link is your unencrypted link, and this part, which is this part, these three are your TOR nodes. So you can clearly see the message or the request is sent from Alice, but when it reaches to Bob, it will think that it is from this TOR node but not from the Alice. But instead it was sent from the Alice, so it was so encrypted that this Bob has no idea which of these node has sent these messages. So you can just now get information that this Alice is searching something on the Google. Maybe this Bob is Google now, and Google has no information that who is sending that information or who is sending that request. So this is the work of the TOR. You can see clearly over here how this is encrypted. And if you just make one request, let me say something like, okay, at first we just made the request to google.com, and in second, if I just make a request again to facebook.com, new circuit will be created now, and this circuit will be random than before. At first this was this circuit associated to make a link between Alice and Bob. Now for the second request, maybe facebook.com, now there will be another circuit created, so that this new server will no have any longer information about this Alice again anymore. So this is a very important encrypted technique in the case of this TOR, and we have to just see that how these circuits are created in the case of the TOR, and how we can just see that green link here is an encrypted one and the red link is the clear one or unencrypted link. That means this will have the information of this node, but this node is of the TOR nodes. So Alice will be having the encrypted communications with this Jane, or basically with this person or with this server, and that is the only way to protect the transportation of data, which is basically staying anonymous in the network. So it is very important features of the TOR, that is it will just make us anonymous in the network. So that if you do any stops, and I won't encourage to do any illegal stops in the TOR, but if you do again, then there will be something that is encrypted link, so that the person who is going to track, so basically I'm not saying they cannot track you, but there will be hard for them to just track if you just use the TOR for the attacking or for any stops that is not legal. So you can see that we have now talked about the TOR. So an analogy, I'll just give you an analogy of the TOR here. So you can just think this TOR is a mailing system where this mail, so basically we are mailing a letter that is received and forwarded by the different people. So here people is a clients, and there can be the connection between the TOR network to or a TOR node. So let's say there is one person who is Mary, and she wants to just send the letter to the Johnny. So what we are just talking about here is a person or a client is making request to another server, maybe google.com. So here we are just making an analogy that Mary is sending a mail to Johnny. So we'll see now how encryption works in the TOR, but the main thing is that she doesn't want to let Johnny that the letter is originated. So basically what we want is Johnny won't have any idea that the letter was originated from the Mary. That means the Google or any other server don't have any information of this Mary. So that is our main priority. So next step to remain the anonymous will be as follows. Let's see how this works. So first of all, Mary, who originates the letter, write a letter. Basically she writes a letter and places it in an envelope addressed to the Johnny in the Boston. So this is, just remember over here, what we just talking about is she places the letter and addressed to the Johnny in the Boston. That means Johnny stay in the Boston or to the server. Basically we'll just say that there is a server in the Boston. And again, Mary places that envelope in the another and addresses it to Susan in the settle. So that means this is the new server, which is our Tor node. So that envelope, which is obviously the message, is also addressed to Susan in Seattle. And again, this Mary places that envelope in another and addresses it to Barry in Dallas. And Mary also places that envelope in another and it addresses it to Bob in Denver. And then Mary places the letter in a mailbox from her home in San Francisco. So basically, this is the place where this mailbox or basically this letter were originated from. So you can just see that this envelope over here represents a layer of encryption. So using the rule that each person in this analogy can only unwrap the first envelope. So just remember that he only can unwrap the first envelope that is sent. So the conclusion or basically the contents remain hidden, encrypted in the most inner envelope. That means if you see the letter or the envelope, which is the layer of encryption, has that letter which is encrypted or hidden in the most inner envelope. So that is your encryption. You can see the Bob is the entry point here, Barry will be middle point, and Susan will be middle point again. So it is exit point, not a middle point. So C will be the exit point. So each of these has basically your Tor nodes. So they are Tor nodes. That means this envelope which we are talking about over here represents a layer of encryption, and basically this content, which is inner content, will be encrypted in the envelope. And just remember that every party over here, which is obviously this Barry, Susan and Job, which is Bob, which is the metaphor for our Tor browser or for our Tor links or a Tor node, will just unwrap the first envelope. So they have the priority to just encrypt the first part of the messages and not the whole messages. So that is very important to think about this Tor browser. We saw how Tor browser works under the hood in this lecture. You can see these are your Tor browsers, and we saw these are your Tor links. They are voluntarily just kept across the world so that it will be faster than before. But you know that Tor, being so much safer than any other browser, has to go through many Tor links. That means it will be slower than any other browser, but maybe it is more safer. So we have the trade-off over here. We just have the slower browser that is more safer in order to do some pen testing. Now let's go to the some of the quick onion link now. So first of all, I have this GitHub link over here. You can just check out from the resource section. So there are quite bunch of a link over here. You can just grab it out. So if I just open this onion link over here, so let me just copy, go to our Tor browser. Let me just paste and just press go. You'll see it will just have the little less internet connection. So basically we have just opened the Tor shops. So this is the way how this onion browser works. So you can just grab anything. It is same as the normal website. You can just make the Facebook. You can also go or surf the social websites, mailing websites. You can also host your websites, do many things. So you can see over here, this has the onion route. That means this is the website of the dark web. You can do many stops from this Tor browser, but let me just remind you of some incident that was happened back in 2013. So there was this Harvard student who was basically, I just remember his name, it may be Kim or something. So he used basically this Tor browser to email bomb. So what email bomb is, he is going to just he was basically threatening the Harvard staff to just avoid taking the exam. So that was very interesting facts that he was just threatening to the Harvard staff not to take the exam, and the IT staffs at the Harvard looked at their logs. So they can obviously look at their internet logs, and that IT staff just identified that Kim was accessing the Tor on the school network during the time of emails. So they just catched him, and just FBI asked that Kim if he did that action, and Kim admitted. So you can see that Tor has worked, but Kim has just broke, because you can clearly see that Tor is not for everyone. If you want to make use of a Tor, make it in a way that it will just be not harmful for other. You can just make your message encryption much more efficient in the TOR. But if you just do any illegal stuff, it will be just tracked by any official in any time. So it is very dangerous to work with the TOR for the illegal stuff. So I highly recommend just you can go through for the educational purpose, or basically you can surf it and you can see how is this onion browser work or onion route work under the hood in this lecture. So in the next lecture will be interesting lecture, because we are going to just launch our own website as an onion route from the Kali Linux. We'll just make our own server, that is Apache server. We'll just make our own website and we'll just host that website in the onion route. So we'll just see you in the next lecture. See you in the next one.